Hey guys, this is another YouTube video for you guys to watch on chemical reactions. Today we're going to go over the third type of chemical reaction. It's called single replacement reaction. It's actually one of my favorites, so let's get started here. It's a very important reaction in chemistry. A lot of things can be done with this, and a lot of substances can be produced with this. And there's a little bit of scientific theory and you have to refer to some special charts and tables and whatnot in order to see if these actually occur or not. All right, so it's not like the first two, it's a little different. It's kind of a step up in a way. All right, so let's get started here. All right, so this here is called a single replacement reaction. All right, single replacement reaction is a reaction in which one element replaces a second element in a compound. So from the name, single replacement, there's going to be one element being replaced. Now, there's two subcategories to this type of reaction, and we're going to look at them one at a time. There's one called an anionic, where a nonmetal displaces a nonmetal, and there's a cationic, where a cation displaces a cation, or a metal displaces a metal. Okay, very importantly, you're going to need to refer to the activity series list. Okay, and we're going to go over that shortly. Okay, in a cationic replacement reaction, I have a little formula set up below here, and we're going to take a look at this here very slowly. Okay. Now, in a cationic replacement reaction, a metal will replace a metal. And we're going to do this in lab. All right. Here we have our metal. It's indicated by the positive sign. Now we have this BC. This is a compound. We have the first element, which is always going to be the metal, and the second, it's going to be a nonmetal. So here is your B. Okay. So, I was thinking like bay. Now, B is actually bonded to C chemically. All right? B has given C its electrons, forming a bond. Now, the only way A can displace or replace B is if A is stronger than B. Okay? So this is a bonded compound. A will come in, okay, and should kick out B, whereas A will now take C, forming a new compound, okay? So, if A is stronger than B, A will take C, forming AC, leaving B by itself. This is the metal that gets replaced. All right. A is stronger than B. Okay, so the attraction force holding these two together is broken by this one. This element comes in, knocks out the B, taking the C. So we have to pay particular attention to these symbols right here for each reaction. You cannot rush through this. You have to look at each one very carefully. Okay, so here is the activity series of metals. Okay, at the top we have lithium, potassium, calcium. Now these three metals react with water very rigorously, where they spark, splatter, bubble, smoke, and pop. Towards the bottom, of course, I have to move the screen down, silver is actually all the way at the bottom. Just think of jewelry. You wear jewelry. Most people wear jewelry. Okay? Silver, platinum, gold is at the bottom. It does not react with your skin. It's non-reactive. Okay, so that's a way to remember. So the ones at the bottom are not as reactive as the ones towards the top. So this is a list. There's many more lists. There's some lists that are like a lot longer, but this one's very basic for learning single replacement reactions first. I have more involved lists as well. So let's take a look at the next slide here. So let's take a look at what happens with an example, iron. Now, let's say we have iron. How do we know iron will displace another element? Well, let's find iron. Okay. Iron's right here. So here's iron. All right. Now, iron will displace copper. Copper's down here. So iron is stronger than copper. So iron can displace copper. Now, iron does not displace zinc or calcium. We have zinc here and calcium up here. So in a reaction, if iron had to displace zinc, it can't. It's below. It's less reactive than zinc. Iron is also less reactive than calcium. Okay? So this is a table that you have to pay particular. In this reaction here, it's a pretty neat one. We have zinc, and we're going to drop it into a solution of copper 2 nitrate. So let's take a look at the products that will form with this reaction. Okay. Okay, so on the reactant side, we have zinc plus copper nitrate. Zinc is your A, copper is your B, nitrate's your C. And nitrate, remember, is this whole entire polyatomic ion right there. Now, for this reaction to occur, zinc must be stronger than copper. So for zinc to come in and for zinc to kick out copper and take nitrate, you have to refer to the activity series list. And in this case, zinc is higher or more reactive than copper. So zinc will take nitrate, forming a new compound. Okay, so you can see on the reactant side here, you have zinc and nitrate now forming a new compound. Okay, and copper was kicked out. So A is your zinc, B is your copper, C is your nitrate. A on this side is zinc, C is nitrate. So if remember, from the puzzle pieces over here, they're going to be refit over here. And then B is your element that gets replaced. Okay, it's the replacement. All right, so this here, we can go ahead and rebalance it. All right, so let's take a look here. And actually, it's balanced. We have 2 nitrates on the left, 2 nitrates on the right, 1 zinc on the right, 1 zinc on the left, 1 copper on the left, and 1 copper on the right. So we're good. We can move on. So let's take a look at the next reaction. You can make silver in a lab. This is really cool. I love this one. Okay. So if we take a little piece of magnesium ribbon and we drop it into some silver nitrate, let's take a look and see what happens. Okay. So we have our A, magnesium, our B, silver, and our C, nitrate. Since magnesium is higher on the the activity series, magnesium kicks out silver. Magnesium then takes nitrate. So on this side, you'll see A, C, and then over here, B, which is silver. Silver gets kicked out. So you have your new compound, magnesium nitrate, being formed. Okay. As long as your element, magnesium, is stronger than your silver, this reaction can occur. So as long as your A is stronger than your B, it works. It'll be a reaction. Okay. So once you finish it, you got to balance, so we want to balance it. So we're going to balance the nitrates first. There's 2 nitrates on the right, 1 nitrate on the left, so I'm going to place a 2 in front here for the coefficient. Okay, the magnesiums are 1, and the silver has 1, but we need to place a 2 over here to balance out the silvers. Okay, Now, this reaction is really cool. It deals with dropping potassium in the water. All right. So let's take a look at the reaction. Starts out clear. Piece of magnesium is right here. It gets dropped in, and bam, there's some fire, which indicates there's a chemical reaction. Notice there's a cloud forming. Okay. And then the water is grayish looking. That's an exothermic reaction, and new products are formed. This water here on the beaker to the far right has a high pH, close to bleach. This actually can hurt your skin. Okay, it's not the same anymore. It's a new product being formed. So let's take a look at the reaction that undergoes this single replacement reaction. Okay, so on the left we have K, and we have this weird H-OH. Well, this is an abbreviated form for water. Okay, water can be written HOH. Just for ease, you have your metal here and your positive charged element here. So here is the single replacement reaction. You have to watch this. Water is a trick. Okay, but it's very easy if you know this. Can K displace or replace H? Yes, it can. The activity series says that potassium is more reactive than the H, so the reaction will occur. Okay? So what happens is your A is stronger than your B. Okay, so potassium comes in, kicks out the H. So then potassium takes hydroxide, your OH, okay, on the product side. So then you have your reaction forming your new AC, your new compound, KOH, plus your B, the hydrogen that gets kicked out. Okay, then you balance it. K, K, OH, OH, 2. So on the right side, there's 3 H's. On the left side, there's 2. So I'm going to place a 2 right here to make it 4, and a 2 right here to make it 4. Okay, so now we're balanced. And then the last is the K. I'm going to put a 2 right here, and then we're good to go. So your C, H, and O, you always start with your C, H, and O, are balanced. So your H are balanced, your O's are balanced, and now your K is balanced. Okay, moving on. No reaction. What does this mean? Well, we have your pen, your A, B, and your C. Now, in this case, your A and your B are actually metals, yes. However, silver is below calcium on the activity series list. So this reaction cannot occur. Silver is not stronger than calcium, so there'll be no reaction. Okay, so this compound right here cannot be broken apart by using silver. Okay, now let's look at the last reaction. We're going to take a second here. Okay, it's anionic reaction. Anionic reaction is where a nonmetal displaces a nonmetal. So your A, okay, replaces your nonmetal. Why? Well, it's a nonmetal. Nonmetal replaces a nonmetal. So your A takes your B, forming Ba. And remember, your metals always come first. Okay, this is the anionic one. So let's look at a reaction. Now, how do you know which nonmetal replaces a nonmetal? Well, it deals with the group 7A. Fluorine's the strongest and iodine's the weakest. So as you go down, the reactivity series decreases. So here we go. Let's look at this reaction here. Now, because we have a Br and an I, your Br is stronger than your iodine, so your Br is going to kick out your iodine, which is the nonmetal. So you have your nonmetal here and your nonmetal here, and your sodium gets kicked out. So you have your A